Welcome to The Explainer. Today, we are going to unpack the incredible story of the technology that connects pretty much our entire digital world, the local area network, or LAN. You know, it's the quiet magic that lets you print from across the room or stream a movie, and how it all came to be, well, that's a masterclass in brilliant problem solving. Okay, let's just jump right into it. Take a look at this. We've gone from 10 megabits per second with standard Ethernet all the way up to over 10 gigabits today. That's a thousand-fold increase in speed. It's just wild, right? But how in the world did we get here? Well, it turns out it all started with trying to solve one very simple problem: a really, really noisy digital room.
So we're going to trace this whole evolution through 5 key stages. We'll start in the chaotic early days of shared networks and end up with a personal network bubble that pretty much surrounds us all today.
But first, let's just get on the same page. A LAN is just what it sounds like, a computer network in a local area. You know, an office, a school, or even your house. And these days, if you're talking about a wired LAN, you're pretty much always talking about a technology called Ethernet. So let's rewind. How did this whole thing even begin? To really get what early Ethernet was like, I want you to picture a huge crowded room where everybody is shouting at the exact same time. It's just total chaos, right? It's messy, nothing gets communicated, and that was the very first big hurdle that networking had to overcome.
See, early networks used these thick coaxial cables that connected every single computer to this same wire. You can think of it like an old school telephone party line. The huge problem? If two computers tried to talk at the same time, their electronic signals would literally crash into each other, creating a data collision. And poof, the information was just gone. The solution they came up with was clever, if, well, not super efficient. It was basically a set of politeness rules called CSMA/CD. That's Carrier Sense Multiple Access with Collision Detection. And here's what that really means. It's simple. Listen before you talk. If the line is quiet, great, you can start sending your data. But, and this is the key part, you have to keep listening while you talk. And if you hear someone else jump in, a collision, you immediately stop, you apologize by sending out a little jam signal, you wait a completely random amount of time, and then you try the whole thing all over again.
Now, this system, it worked. Kinda. But it was incredibly slow, especially as you added more and more devices to the network. That noisy room just kept getting louder, and data collisions were happening constantly. There absolutely had to be a better way to manage the conversation. So how do you fix a loud, crowded room? You don't just ask people to be more polite. No, you build smaller, private rooms. And in the world of networking, these private rooms were created by two hero devices: bridges, and then the real game changer, switches. And this slide right here shows you everything you need to know. An older device, a hub, was basically just a megaphone. It heard data come in one port and it just shouted it out to every other device on the network, keeping that loud room problem very much alive. A switch, on the other hand, is like a super smart postal worker. It looks at the destination address on each packet of data and creates a private direct link just between the sender and the receiver. And this is the most crucial takeaway. Switches completely eliminated the collision problem, period. Instead of one giant, chaotic mess of a collision domain, a switch creates a tiny, dedicated, collision-free lane for every single device plugged into it. It was like giving every single conversation its own private, soundproof room. And because these links were now private, it enabled something incredible called Full Duplex Ethernet. Think of it like this. We just upgraded a single-lane road to a multi-lane, two-way highway. Data could now be sent and received at the exact same time, effectively doubling the potential bandwidth. And all those old polite CSMA/CD rules, we didn't need them anymore. They became totally obsolete. Okay, so with the chaos of collisions finally tamed, engineers could now focus on the next big challenge: pure, raw speed. The conversations on the network were quiet and orderly, but now we needed them to be faster, like way, way faster. And the pace of innovation here was just breathtaking. In 1995, fast Ethernet came along and boosted speeds by 10 times to 100 megabits per second. But then, just 3 years later, we saw another tenfold leap. Gigabit Ethernet arrived on the scene. 1 gigabits per second. That's a billion bits of data flying through a wire every single second. It was a monumental achievement. But the real question was, how could you possibly deliver that kind of incredible speed using the standard copper cables that were already inside the walls of every office building? The solution was nothing short of an engineering marvel.
Gigabit Ethernet uses all 4 pairs of wires inside a standard cable, and it sends data in both directions on each pair, all at the same time. It's like turning that 2-lane highway into an 8-lane superhighway. Then they added a super clever encoding technique called 4D PAM5 to squeeze an absolutely enormous amount of data through those wires. Just brilliant. But, our hunger for connectivity wasn't just limited to wires. We wanted to be free to cut the cord. And so the same principles, managing a conversation, avoiding chaos, now had to be applied to the invisible world of radio waves. So how did they do it? How did engineers solve all these same problems for Wi-Fi? I mean, how do you possibly create an orderly conversation when the room is literally the air all around us and everyone is trying to shout at once? Well, wireless networks get organized into something called a basic service set, or BSS. And there are really 2 main flavors. You've got an ad hoc network, where devices talk directly to each other, kind of like a small private group chat. But what's way more common is infrastructure mode, where a central wireless access point acts like a traffic cop or a meeting moderator, managing the entire conversation for everyone. And here's where the magic really happens. When you link a bunch of these access points together using a good old-fashioned wired Ethernet backbone, you create what's called an extended service set. This is what lets you walk across a huge university campus or through a big office building while you're on a Wi-Fi call, and your phone just seamlessly hands your connection off from one access point to the next without ever dropping. It's amazing. So we've gone from these huge campus-wide networks. Now let's zoom our focus all the way down to the smallest network of all, the one that exists only around you and your personal gadgets. And of course, this is the world of Bluetooth. It's specifically designed for short-range communication, creating what we call a personal area network, or a PAN. This is the tech that connects all the devices immediately around us, your wireless mouse, your headphones, your smartwatch, all talking to each other. Bluetooth is really cool in how it organizes these little conversations. It creates piconets. You have one primary device, like your phone, acting as the master, and it can control up to 7 other secondary or slave devices, like your headphones or your keyboard. And you can even link multiple of these piconets together to form a bigger, more complex network called a scatter. So when you step back and think about it, in just a few short decades, we went from solving data collisions on a single shared wire to building this seamless, invisible bubble of personal connectivity that literally follows us everywhere we go. It has been such an incredible journey of innovation, and it really just leaves you wondering, what on earth will we connect next?